Hey everyone, thanks for tuning in. Today on this video we're going to set up a new part template from the SolidWorks default template. As you all probably know, SolidWorks default settings aren't always what we want to use when we're setting up and making our parts or our drawings or our assemblies. So for starters, we're going to go ahead and create a new part template, and then I'll do a part 2 of this series, which will be doing an assembly template, and a part 3, which will be setting up a basic drawing template for outputting our drawings once we're done with a part or assembly. First things you're going to want to do is you're going to come up here to your new part. It's wanting to go ahead and set some information here, units and whatnot. This is a first time thing. If you're first time opening your SolidWorks and you're getting ready to start this, it'll ask you these questions. It doesn't really matter what it is right at the moment because we're actually going to be changing that in the settings as we create our template. So I'm going to go ahead and leave those exactly how they are. Okay, so you get this window. This is a very basic window. I highly recommend that you get used to using the advanced window. The advanced window here is going to give you more options, and you can load more folders into your file search path for different types of templates that are located in different places on your computer. There really is no difference between tutorial and templates here. All these files are just default templates that are in SolidWorks already. There's nothing wrong with them, but at the same time, you, for your personal use or for your professional use, may want to have or have the need to have a custom template set up for the formats in which you're using, whether it's in the units or styles, etc. So like I said, we're going to start with parts, so we'll go ahead and open the default template, which will give us a new blank part template. Now the first thing we're going to do now that we're in here onto this part, we can take note that down here in the bottom right you can see where the unit system is identified, and at any given point in time, whether you're in a part, an assembly, or a drawing, you can change the units. It just becomes tedious to have to change it in every single drawing. Say you're using metric standards but your template is in IPS like this one is, and you have to change your units with every single part that you open. So for that purpose, we're going to go ahead and set up a specific template for IPS, ANSI standards, and also adjust some layering and some dimensioning formatting. To do that, you'll come up and you'll select Options, and then you have all your general options, which these are global options within SolidWorks. At some point later on down the line, I'll probably do a video going through those and showing how to optimize performance and display settings based on your computer system. But we're going to go ahead and leave all of that as the default SolidWorks settings for now, because this video is about the document and the template. So to do the template settings, you'll come over to Document Properties. First thing we'll look at is the drafting standard. For my personal use and my professional use, I use ANSI standard. It is a fairly global standard, and it's a good baseline to go with if you're not sure. Otherwise, if you do know what standard you're using, you're more than welcome to choose it from that list, or if it's not on that list, you can load from an external file from someone else within your company or another source of that note. After that, you can check here all uppercase. I don't do that. I have my cap locks key when I want all uppercase, so I'm not going to worry about that. Then you'll come down to Annotations. For Annotations, this is where you can set your text font. Default setting on SolidWorks, as you can see, is the Century Gothic. You also check your attachments, your arrows, your face of a surface. Basically, it's going to use this arrow whenever you're putting a note or dimension to a line or whatever of those lines. It's going to use this arrow to point to an edge if you click on the edge. If you're putting something on a note that's attached with a leader to the surface, it's going to use this dot. And then unattached, if it's not attached to anything but you have a leader, it's going to give you an arrow. Bent leaders are a great thing. That's basically where you have a straight leader that comes up and then has a horizontal platform on it. In my opinion, they give a cleaner, neater, easier to read look to your drawing. That said, the default setting in SolidWorks for the length of the landing on the bent leader is 1/4 inch. I prefer that to be set to 1/8 of an inch, so I'll punch that in directly. Now my bent leader will have 1/8 of an inch landing instead of 1/4 inch landing. Leading zeros, I'm going to leave that to standard. Trailing zeros can be to smart right now. At some point, actually leading zeros, we're going to remove those. Trailing zeros is going to be set to smart, and then when you're doing those in dimensioning and stuff like that is when it'll come into place how that smart works and how many zeros you actually set to go in. But for the standard document settings, we're going to leave it set to smart. Next, you'll hit this little plus sign next to annotations, and then you got a whole bunch more things that you can go through. Balloons, there's a lot of different types for balloons on how you do them. The default balloons are how I typically will leave them. 2 character size balloon means the balloon is sized for 2 characters. If you have 2 characters in it, it works well. You can downsize them or upsize them as you desire, but 2 characters seems to be the best that I've ever worked with. I haven't had the need for them to be any larger, and they don't look too big when it is only 1 character. Again, here you have some options for how the balloons look. See, that doesn't give us, oh, that's bent leader again, that's for the landing. I prefer not to have landings with balloons. See, there's where that landing comes in. Actually, you know what? That's not too bad, but I will change the leader length to 1/8 of an inch. Oh, that's a critical mistake. This is something you'll probably do over and over again, just out of habit. What happened there is I hit enter after I punched in the size, so it closed out my window. When you punch it in, don't hit enter, just click out of it in a different area. Come back over here, 0.125, click out of that. Now it's shortened up that landing on the bent leader, and I'd say that's about what I'm going to go with on that one. Other than that, I think everything looks good here. Again, the font, if you want to run a different font, that's where you're going to change it there. Different settings on how you apply balloons in different layouts. This is what I'm going to run for now on them. Datums, if you're doing datums, if you know what they are, GD&T, that sort of thing, this is where you set up your datums, different leader types, so on and so forth. For this template, I'm not going to do datums. I'm not going to do GD&T on this template, but this is where you'd set that up. Notes, again, here's your leader size. This is checked to use the document leader length we set originally, which is that 1/8 of an inch. You can see it's already shortened out. There's that arrow going to an edge or floating. So everything is good there. We're going to go ahead and move on to, alignment, text alignment. There's different places you can do that. It doesn't really show you what the differences are here. You can't see it because there's nothing to reference against. Default setting was to the left, which is pretty standard, so that's what I'm going to leave it on. Revision clouds, if you use revision clouds, you can change how they look here. The default setting for SolidWorks is not too bad for that, so I'm going to go ahead and leave that alone. Surface finishes, you can edit the style of the surface finishes right here. Again, the leader display for surface finishes, you definitely want bent, but you probably want to adjust the document leader length so that the landing is slightly longer. Uncheck document leader and then put in a length that looks appropriate for what you'd like to see. And then we'll click out of that so that it modifies. And see, that looks a little bit better, but it's a little bit long off to the left of that, and there's no way to adjust it to where the surface finish information is centered on that landing. So I'm probably going to back mine back off. We'll go with 0.1875. Let's see how that looks. I'd say that looks about right for that one. I like the look of that, so that's what I'm going to stay with on the leader for that one. Welding symbols, again, if you use welding symbols, right here is where you're going to edit them. I'm not going to change that at all. And then we'll move into dimensions. Dimensions where you're going to want to make the most changes, and you'll want to make sure all your settings are right in your template, because if the settings are wrong in your template and you go and you do the drawing, you got to go back and change and fix things for each individual dimension, or delete everything, fix the settings, and start from scratch. It can be really time consuming and annoying. Not only that, it can be costly because time is money. So font, you'll select your font here, and your arrow size. The default arrow size is fine by me for what I want to do. The arrow leader length and everything on that is perfectly fine. Primary precision to 2 decimal points, that works for this template. Style, if you want to run different types of arrows, personally the closed filled arrow is what I prefer. And then offset distances. Here's one that I don't like SolidWorks' standard. I think they're too close together, and so I'll change that. I prefer to have them set to 1/2 inch off the part. Oh, there I went with the enter key again. I'll open that back up. Go back to my document properties, my dimensions. Okay, so we set that to 1/2 inch, and then I set each one past that to 3/8. Now, as you can see, when I punched this in, I punched it in as a decimal, punched this in as a fraction. It works exactly the same. It converts the fraction to a decimal. So if you want to use those to punch stuff in, it works. Feel free to do it. Stacked fractions. This will show how your fractional display is if you have fractions in your drawing. Personally, I prefer slanted fractions just because of the look of them. I like the way they look, so that's why I do it. And I reduce the stack size to 80% so that it's not quite as tall. It makes it about pretty close to even with the rest of the text that the fraction comes up next to. Leader length for the bent leaders. This one is going to be set back to 1/8 of an inch. So we'll leave that. Leading zeros at standard, trailing zeros set to smart. And that's it in this one for the settings. And then you got that little plus arrow, and you can open it up again. We will want to click through on each of these. You can pick your different styles of where you have your degrees set, what the angles are at. I prefer horizontal break degrees for the angles. Using bent leaders, there's where you set the font, set where it breaks it at. Precision 2 decimal points. You go back into the tolerance section right there to set tolerances, but we're not going to do that. Move on to the next one, angular running. That works just fine. I don't really use angular running dimensions in any of the stuff I do. I find other ways to dimension it, as I don't like that dimensioning style, but there it is if you want to edit it. Arc length, that's another one I don't use, so I'm not going to bother changing anything on it. Chamfers. Chamfers I do use, although I don't prefer the one that they used here. I prefer the next one over, just because the way the bent leader looks. Oh, nope, I take that back. I don't like the underline. This is the one I don't like. This is the one I do like. I don't like the underline under it. Nothing else has an underline, so that's what I stay with. Distance angle is the chamfer style that I prefer, but if you want distance, angle then distance. There's the different options of how it'll output the information. So you can see just by clicking that bubble, it changes what the information is there. Again, distance angle is what I prefer to use. Precision is here. Leaving that as is. Font is, if you want to change it's right there. And you can go to tolerancing as well from here. Diameter, same thing, same settings. Go through, pick your text position, text size, font, so on and so forth. Precision, whole call out, same basic thing. Pick your precision, your document settings, where how and position for where the dimension's at and how you like it. You repeat this for each one of the different values here. I'm not going to really change much. Most of them are acceptable the way they are. Ordinate dimensioning. If you use ordinate dimensioning, this is where you want to come in and set that up. I don't do ordinate dimensioning most of the time. And if I do have to use it, usually it's a very specific situation in which I'll set up proper settings in that specific document for it. So we're not going to waste time doing ordinate dimensioning changes, as the defaults fit our basic parameters for this template. Radius dimensions, let's see what the other options. No, don't like the way that looks, but if you like that, there's that option. There's the straight leader, or there's the bent leader. Again, I prefer the bent leaders. That uses the document standard of that 1/8 of an inch. Center, middle, dimension, smart arrows follow, yep. And that'll cover that one. Virtual sharps. These are extension lines that are brought off the corner of the part for dimensioning when you run them. Personally, I think having the overlap is the most obvious, but if you want to just have the plus where the corner would be, that's not a bad way to go. The star, well, I don't know when the star would ever be acceptable. Who thought that was a good idea? I can see the dot being useful for some. No overlap or passing, that possibly, but it could get mistaken on a black and white drawing for being part of the part, not just an extension of the part to show where a corner would be measured from. So that's why I like to go with the witness. Okay, moving on. Let me shrink these out of the way. Go into tables, bill of materials. This is basically, once you have your bill of materials set up, when it comes into the part, it's going to use these line thicknesses for the grid box it'll create around the bill of materials information. That can be set up elsewhere as well, but this is one place you can set that up, as well as choosing the font and this information, whether it uses dashes for zeros, uses a 0 for a 0, or is left blank if the value is 0. I prefer to have it left blank if there's a 0 value. No point in wasting the ink to put something there that needs no information. If you have a missing component, if you have an assembly and it's missing a component and you want to make sure that there's a box left for that component that's missing in the bill of materials, you would check right here. It's very atypical for me to have an assembly put into drawings that has missing components that aren't intentionally missing. So I'm not going to bother checking that. If I need to fix or adjust one, then I'll just do it individually later on down the road. Leading zeros and trailing zeros, same as all the other ones. Set to document standard for the leading zeros, smart for trailing zeros, no big deal. Quantities, things of that sort, these are all just specific to what you want to have on your bill of materials. One that I don't recommend checking until after you mess with your bill of materials is most of the time when we put an assembly in, we want to know every single piece that's in that assembly on the bill of materials. If you check this box right here, it's only going to give you bill of material based on top level assemblies within a major assembly. So if your assembly has 3 assemblies within it that each have 3 parts, you're only going to get the 3 assemblies on your bill of materials. You're not going to get all 9 parts. So I don't recommend checking that. I recommend using that type of feature, which you can access from the bill of materials tool. when you're actually putting one in. Only use that when you really only want the upper level assembly and not all the parts. But most of the time we want the parts, so you don't want to check that. Automatic update of a BOM, that's what's going to go and access the parts and make sure the BOM is always up to date whenever you make any changes. So that's a good thing, but at the same time that can also add load time between transitions between parts and documents. So if you have a system that isn't real high power, you could turn that off and just manually refresh the bill of materials, and it could save you a little bit of time. If you figured, say, maybe 3 to 5 seconds on a document and you open 10 documents a day, it saved you a minute, which over a year is 365 minutes, well, 250 something minutes for the number of work days saved in a year. That really calculates out to a lot of time once you start adding it up over a longer period of time. So your call. I'm going to go ahead and leave it checked. My computer does BOM updates really quick, so I'm not too concerned with that. General, more BOM, general settings, title block table for the BOM. If you want the title block to have thicker line weights or a different font. Moving on, detailing. Cosmetic threads, these are datums, datum targets. These are all, you decide what information you want to show up or not show up. Different bits of information. The more you have showing up on a drawing, the longer it's going to take for it to show up, or into a part for it to show up. Things like cosmetic threads take longer for your GPU to populate the information for them, and can make parts load up on information really quick. That said, cosmetic threads are way better than cutting actual threads onto each little bolt, because it's a simple graphic that's put over a part versus a whole bunch of extra faces and geometry that's got to be measured. So if that's one thing to play with. If your computer is lagging a little bit and you have a lot of bolts with cosmetic threads, you can come in and uncheck this and it'll probably make a difference for you. Again, little boxes, not much really to mess with here when it comes to setting up the template. Dangling dimensions, I don't really or haven't run into situations where these really have had any effect for me, so I'm going to go ahead and move on from those. Grid, I don't use grid in SolidWorks really ever, so that's your call. Set up your grid snaps. So it's a method of modeling which I haven't found a lot of use for, but could be useful and by setting specific grid snap distances. Again, this is something I would say is more likely to be more used by individual documents rather than as your template, so I'm going to leave this alone for the template. Units, for my system I use IPS. I prefer inch, pounds, and seconds, but that said, you could create two separate templates, one that's in metric, one that's in IPS. That way when you go to start a new part, it'll show up, well, I'll show you where it'll show up once we're done with our template and how you load that, so that you know where your template's at and how to start straight from your template. And that way, if you have multiple templates, you can have them all in the same place and just pick which template you want, and it'll have all the drafting standards that you want for that specific template. So IPS, that's all I'm going to do on that one. These basic settings are fine for this basic template. We'll go ahead and move on. Model display, wireframe, HLR. There's a lot of different options here. I don't know what all of them are. I haven't messed with a lot of them. I'm not going to mess with a lot of them. Wireframe, HLR seems to have given me the results that I like. It's the default setting, so we're going to go ahead and leave that and move on to material properties. Material properties, not much really to change here. This is where you can change your hatch patterns for different materials. The density, yep, not really anything to change there for the basic default template. That's stuff you're going to change per specific part that you make. So image quality is something you will want to adjust. If you have a high-end computer with good graphics card and a good processor, you can take this and you can ramp it up here and not see a loss in performance. That said, the higher this is, the more loaded work it is for the computer to run it. Again, since I'm working off of a laptop to do these videos, I'm going to go ahead and pull this down this way a little bit, help keep it, make sure it stays smooth while I do videos. Optimizing edge length for higher quality, but it's a little bit slower. Again, this is another one that'll give you a little bit better graphical representation on your screen, so it'll look a little sharper, a little bit clearer. I'm not going to check it for the same reason I pulled this down. On my desktop, that's a workstation, I have that checked, and it is a little bit of a difference, but I think the bigger difference is the workstation graphics card rather than that box being checked. The wireframe high quality, that I will actually bring up just a little bit so it gives me a nice sharp image there. It counteracts what I did here a little bit to still kind of keep me right about the middle and give me a little bit better on my actual wireframe lining around my part. So this should help sharpen up those edges a little bit without overdoing it. You could click on go to performance, but that would take us over to system options, and that's something we're going to talk about on another day, so we're going to go ahead and move on. Sheet metal settings. If you work with sheet metal and you do the sheet metal stuff, then you probably already know what these settings are and have worked with them. I'm not going to get into sheet metal. I don't work with sheet metal. Maybe at some point later on down the line we'll work on that. Weldments and weldment profiles, just go ahead and leave them all checked. At some point later on down the road, I will do a video on where to find and how to upload weldment profiles into your library so that you have a lot more profiles than the stock built-in profiles, because it only comes with a handful with a few size selections, and there's actually a lot more out there that's pre-made, already existing. All you got to do is load it into the directory and tell it where it's at. So another video for later on down the road. Plane display. The standard colors for the planes, I believe, are green and red. Green for the front, red for the back, and they're nearly transparent. The transparency for them, I like where it's set out of the box, so I'm not going to adjust that. But if you want your planes to look a little bit more solid, you can grab this and pull it down here. Planes will look more solid. I like them fairly transparent, so I'll leave them. If you want different colored planes, you can come in here and select them. Oh, I was wrong. Current default is blue and red. So I'm just going to go ahead and leave them the default. It's not going to waste your time picking colors. Oh, maybe it wasn't blue and red. That shows the same there. Anyways, you know what they are. Different years of SolidWorks, they've probably been a little bit different. But anyway, that's where you change your plane colors. Moving on, Dim Expert. Dim Expert is a fairly useful tool. I'm not going to adjust any of the settings. Typically the settings I do anytime I'm doing stuff with the dims, I do it within the document as I'm doing them. So we're going to go ahead and leave the Dim Expert and all of the dim options just as they are. And then you have configurations, and we're going to go ahead and leave that unchecked. It was one more thing that it's going to add a rebuild when it's saving marks to configurations and whatnot, and it'll slow your computer down a little bit with one extra thing it has to do while you're trying to work. You get into a big assembly that can take, a minute for a rebuild, and it is possible. I work with some assemblies that clicking rebuild means waiting 2 to 3 minutes for the computer to finish what it's doing before you can move on. So if you're just trying to hit save on a configuration and then it has to go into a rebuild, imagine if you have 10 configurations at a minute of rebuild, that's 10 minutes of your day gone just to save your document. So I would recommend leaving that unchecked unless you have a real high-end workstation computer, then it can probably handle doing this. Or if you only work with small configurations or individual part configurations, then you could probably do that, not see any lag on it. So now at this point we have all of our settings for our this basic IPS template set up. So we're going to hit OK down here, and now the question is, how do we make sure those settings stay the same the next time we want to get on? You'll come up here, you'll click on Save As, and this will take us out to our save. typical save location wherever we last saved something. So I'm going to go ahead and go over here to my Documents folder, and I'm going to create a new folder in here, and I'm going to call it Custom SolidWorks Files. Open that folder, and then we're going to call this IPS Basic IPS. And instead of saving it as a part, you'll drop down this menu and you'll save it as a part template. This is going to be the third one down, part template, prt.dot. Basic IPS. Oh, and it relocated my search path to the templates folder. I don't want it in the templates folder because I want it to be easier to find than going to Program Data, SolidWorks 2015 templates. By making it easier to find and putting it in this folder, my Documents folder, then if I want to share that template or transfer it to another computer, it makes it really easy to find what my custom SolidWorks files are that I made versus the default ones. So I'll save that there. Now, when we close this out, those settings, meant to close the document, not SolidWorks, no big deal, we'll reopen here. But when I go to open a new document, we're going to go ahead and see if our document's there. So I'll click here, and you'll notice that Basic IPS is not here. I still only have templates and tutorials. So now how do we get that here? Go ahead and hit cancel. You'll come back up into your options. Now since we're not in a document, you don't see the document settings at all. But we don't need to go into those. We need to come down to File Locations. When you get to File Locations, it should default into Document Templates here. But if it's not in Document Templates, hit the drop down arrow, navigate to Document Templates, which should be at the top, and now you want to add a file location to your document templates. Once you hit add, you'll navigate to wherever your custom SolidWorks files are. This one was Documents, Custom SolidWorks. Select that, and then select OK. Now my custom SolidWorks file is added as a document location. You'll hit OK down here. It wants to know if I really want to do that. Say yes, yes again to confirm it, yes again. OK. Now when I click here, I have 3 tabs. Custom SolidWorks file, Basic IPS. There it is. Now I want to move this tab to being at the front so that when this first pops up, I get my custom templates over the default templates every single time. In order to do that, you'll come back in to File Locations, click on your custom SolidWorks files, and then just click Move Up 1 or 2 times, depending on how many files you already have here. Moves it to the top, and then just click OK. We go for a new document. Oh, it didn't move it up the second time. Okay, so maybe I missed a click. Let's go back and check that. Come in here, File Locations. Interesting. Well, if it's going to be that way, because I know I don't need them, well, I still have 2 more templates to make, so we're going to go ahead and leave those there for now. After I make my assembly template and my drawing templates, I'm going to remove these completely by deleting the file location. If you delete the file location of the default templates will still be in your SolidWorks at these locations. So all you would have to do is go back and re-add them back in, and you would have them back. So I'm going to go ahead and leave those for now. And then for whatever reason it's playing a trump card, SolidWorks is, and it's keeping the default templates made by SolidWorks ahead of my templates. No big deal. After I make my other templates, I will delete that file location, and this will be the only one that comes up with all of my custom templates. So there you have it. Basic IPS. Hit OK. we come in and all of our document settings that we adjusted, our general dimensions, our leader lengths, all set to 1/8 of an inch, offset at 1/2 of an inch and 3/8. All that stuff's already correct so that it all comes out exactly how we want. If you have any questions, feel free to leave them in the comments below, and I'll get back to them as soon as I notice them. Thanks for watching. If you or if you have a suggestion on something you need help on, let me know, and I'll see what I can do. Thanks.